H. Then this one join with arrow. This is the functional group for alkanes. So for this pentanal now, we are going to have 5 carbon atoms. So we're going to have 1. Alright, now let's start with this compound. Let's start with this compound. Let's say we have we are asked to write the structure of 2,3 dimethyl benzene. 2,3 dimethyl benzene. Now look at how to get this structure out, the structure of this compound. How can we get the structure of this compound? That is, how can we get the structure now from the name, not from get the name from the structure now. That's what we are trying to do here. Now what you do, the first step is to get the parent name of that name. The parent name will always be at this last side. That's where the parent name will be. So you have the parent name there, and the parent name is hexane. That's the parent name. So you write out a structure of hexane, because that is the longest chain there. That is the parent name. So the structure of hexane has what's it called? 6 carbon atoms. Let's just bring out 6 carbon atoms. We have 1, 2, 3, 4, 5, 6. This is hexane. This is hexane. And the next thing, we have 2,3 2-methyl. We have 2 of methyl. And okay, let's say we have 2,3 dimethyl. Di means 2. That means we're having 2 methyl group there. Now, the first methyl group is located at the second carbon, while the second methyl group is located at the third carbon, depending on where you are counting from. So let me just, so I think it will be very simple. Let me just count from here. 1, 2, 3, 4, 5, 6. So our second carbon will be 2. You just put 1 methyl group there. The third carbon will be this. Put another methyl group here. So this is the structure. This is the structure now of 2,3 dimethyl hexane. Simple as that. Simple as that. Simple as that. And you can also do it this way. You can also do it this way. It's also possible to do it this way. It's also possible to do it this way. In case you see something like this, also do it this way. You first of all draw. We have 1 carbon, 2 carbon, 3 carbons, 4 carbons, 5 carbons, 6 carbon. We have 1, 2, 3, 4, 5. This one is even more than 6. So let me just remove 1. We have, that is 2 carbon. That will give me 3 carbon. This one will give me 4 carbon. This one will give me 5 carbons. 1, 2, 3, 4, 5. This one will give me 6 carbons. We have 1, 2, 3, 4, 5, 6. Then let's start putting the stuff now. We have 2, 3. So 1 is here. We have 1 this thing here. So what you just do? What you just do? Just close this one. That's number 2. So you put 1 carbon here, and you put the other carbon here. So even though you don't even put right carbon, there's no problem. You just put 1 line here. One line here, 1 line there. That's all. This one is still 2,3 dimethyl hexane. So you can also write it this way. You may even decide to write it this way, safe. If you decide to write it this way, you start counting from this end. 1, 2, 3, 4, then number 6. Then after numbering, you have a one methyl group here, so you just number 2, you put one line here. You have another methyl group in number 3, you put another line there. That is all. You can also see it this way. So please is how we roll here. Let's take another question now. Now let's look at this second question. So you have theory, ethyl. You can start with calculator, no problem. 3 ethyl, 2 3 dimethyl heptane. Because of space, let me move this one to this other side. Heptane. So this is the name. I want to get the structure. So I told you the first thing you do, go to the last name and note it. Note the last name, that is all. Then draw the structure of the last name. The structure of the last name is heptane, which is 7 carbon atoms. Hept, we have 1, 2, 3, 4, 5, 6, 7. Then you count. I may decide to count from anywhere. I'm trying to count like this: 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Anyone you like, you follow. Because numbering will not be a problem here, because you are the one to number it yourself. So the thing now is just to, what you need to do now is just to place the substituents in the exact position that is located to the substituent in the major name or the name of the compound. So let me just use one of the number. Let me just use this one. So we have 3 ethyl. We have 3 ethyl. So we have ethyl in the 3rd carbon. So just put ethyl here. We have 2. That is ethyl. Then we have 2 methyl. We have 2 methyl. Then you go to the 2nd carbon, you put methyl there. That's methyl. You also have 3 for methyl again. You go to the 2nd carbon, you put methyl here. Methyl. So this is 2 3 dimethyl. Then 3 for ethyl. This one is ethyl now. This is methyl, and this is methyl. So this will be the correct structure for this compound. This is the correct structure. So please take note of that. You can also decide to do it this way, in a very short, using lines. So you decide to do it this way. Let's say you have a 1 carbon, that is 2 carbon atoms, 3, 4, 5, 6, 7. Then you number 1, 2. You can number it from here as well. You can also say 1, 2. There's no problem. Just that I want to start from the other side. 1, 2, 3, 4, 5, 6, 7. So you put ethyl here. Ethyl will look like this. That will be ethyl. Then this one will be methyl, because we have already done this. This will also be no. Ethyl is in the 3rd carbon. Ethyl is in the 3rd carbon. So you put ethyl here. That is ethyl. Then this one will be methyl. That will also be there. Then the another methyl will be here. So this will be the structure of this compound now. You can also do it this other way. So that is it. So let's look at this third one. di methyl butyl noic. Then you can see acid, butanoic acid, or you can leave the acid part. So to write the name out now, therefore I told you, get the last this thing, get the last stuff there. The last stuff there is butanoic. So you draw the structure of butanoic. So we are going to have something oic group there, which is for acanoic carboxylic this thing, which is like this. So we're going to have this one there. This is already having 1 carbon atom. So let's just add 4 to this. Then 3 more. 1, 2, 3. So if you want to number, you start counting from where the functional group is. That's another thing. Start counting from where the functional group is. Even though it's alkana, alcohols, I2Z, you start counting from where the functional group is, please. You're going to have 1, 2, 3, 4. So therefore, we have 3 for this methyl. So you just put 1 methyl group here, for another methyl group here, the number 3. So this will be the structure of this 3,3-dimethyl butanoic acid. So this will be the structure. So let's look at another, just the last one now. Look at this one. 2, 2, 3. Try methyl pentanal. 2, 2, 3 try methyl pentanal. So that is the question. Alright, so the first you do, check the last name. That's the major thing there. Check the last one. The last one will tell you the kind of compound we are having, which is pentanal. And check this functional. We have we are looking at alkana now, not alkanes. You will first draw the functional group for this pentanal. So how do we draw this functional group for pentanal again? Pentanal is like this. Functional group for pentanal. Alkanas are like this. O will be here. Yeah. Hydrogen will be here. Then this one will go and join with alkyl groups. This is functional group for pentanal. Or you also do it like this. OH, O here. Hydrogen here. This one will have R. You can also do it this way. Okay, let me just use this. So we are going to have it this way. We have C, O, H. Then this one join with R. This is the functional group for alkanas. So for this pentanal now, we are going to have 5 carbon atoms. So we are going to have 1, 2, 3, 1, 2, 3, 4, 5. Then if you want to start counting, you start from this where you have the functional group. Use 1, 2, 3, 4, 5. So we have 2, 2 for methyl. Put 1 methyl here. Put another one here. Then 3 again. Put another one here again. This one give us 2, 2, 3 trimethyl pentanal. Because of this functional group, that's why we are having this now here, not 8. So this is the structure of 2, 2, 3 trimethyl pentanal. You can also do it this way. It's also possible to do it this way. It's also possible to draw it this way by using this line method. You just use 2 double bonds and indicate this oxygen, and once you go bond and indicate this hydrogen, then we have this, we have this, we have this. We have 1, 2, 3, 4, 5. So we have 1 alkyl group here, Another alkyl group here. Another alkyl group here. This is also correct. For this 2,2,3 tri-methyl pentanal, this is also correct. So this is how we draw structures, but those that have functional group, and name those that also have a functional group. Now let's look at this last question. Will be our last question. Let's say for the compound hepta 1,3 diene 6-ine. Let's say we have hepta 1,3 diene 6-ine. What is the correct structure for this compound? What is the correct structure? Now, I told you the first you look at the last name, but if you check this last part, the last part of this question now, check it very well, is not in the homologous series. This is just telling us the position of the, remember, in means what? Double bond. Ine is talking about triple bond. Ine is talking about triple bond. This one is talking about triple bond. Talking about triple bond. 1, 2, 3. That other one is talking about triple bond. So what do we do now? The only name in this place now, in this last side that is homologous series, is this hepta. This is the only name from the homologous series. So the parent name now is hept, which is 7 carbon atom from the homologous series. So we are not going to, this is just showing the position of the both double bond and triple bond. I repeat, for this compound now, this last part is just showing the position of the double bond and what? And triple bond. So please take note of that. It's very, very important. So if you want to do it now, it's telling us that we have double bond, which is in number 1 and 3 carbon atom, and we have triple bond, which is ine, in the number 6 carbon atom. So we are going to count, we are going to draw 7 for hepta. 7 carbon atom, we have 1, 2, 3, 4, 5, 6, 7. Then we'll count. Let's count 1, 2, 3, 4, 5, 6, 7. So let's start placing our bonds now. Now we have double bond in the first carbon atom. So go to the first carbon atom. In front of the carbon atom, you put the double bond there. So sorry, okay, that is double bond already. Then in front of the third carbon atom, you put a double bond there as well. Then in front of the 6th carbon atom, you put triple bond there. This is the name for hepta 1,3 diene 6-ine. This is the name. Now another question that can also pop out from this place is, maybe they will ask you, how many sigma bond and pi bonds do we have in this place? So to get the number of sigma bond, you have to show all the bonds carbon is making with either with carbon or with hydrogen in this structure. So a carbon atom will have maximum of 4 bonds. So if you check this one, now this one is already having 4 bonds attached to it. This one is having just 1. This first this last carbon there is having just 3 bonds attached to it. We add 1 more. That is already 4. Then these carbon atoms, that is carbon 5, is having 2 bonds attached to it. We add 2, I'll make it 4. Then carbon 4 is having 3 bonds attached to it, which is this and this. 3 bonds attached to it. So we add 1 more. That is 4 already. Then carbon 3 also have 3 bonds attached to it. We add one more. That will give us, that will be 4. Then carbon 2 is also having 3 bonds attached to it. We add one more. That will make it 4. Then carbon 1 is having 2 bonds attached to it. We add 2 more. That will make it what? 4. We add 2 more. 1, 2. That will make it 4. So any single bond here represents a sigma bond. Take note of that. So all these new single bond I just added, they are the bond with what's it called, the hydrogen. If they ask you what is sigma hydrogen carbon sigma bond in this compound, that is hydrogen carbon. Maybe they'll ask you how many hydrogen carbon sigma bond. That is how they do write it. That is sigma bond and this compound. Now the new bonds I just added to the structure now are the hydrogen sigma bond. That is single bond in this compound. How many that I added? How many? I added 1, 2, 3, 4, 5, 6, 7, 8. I added 8 to it. Added 8 to it. So we have 8 hydrogen carbon sigma bond in this place now. 1, 2, 3, 4, 5, 6, 7, 8. Then how many carbon sigma bonds we have in this place? They can also ask you that. How many carbon sigma bond? Now each multiple bond we have only one sigma bond and others will be pi bond. Take note of that. If you have double bond, we have one sigma bond there, the other one will be pi bond. If I have a triple bond, we have one sigma bond there, the other 2 will be pi bond. Take note of that. So we have 1, 2, 3, 4, 5, 6. We have 6 what's it called, 6 carbon sigma bond here. So 6 plus 8, that's already 14. So we have we can say we have 14 sigma bonds in this structure now. Then pi bond will be 1, 2, 3, 4. We have 4 pi bonds. We have 4 pi bonds. 6. We have 6. We have 6 sigma bond for carbon. We have 8 sigma bond for carbon hydrogen, and we have 4 pi bond. We have 4 pi bond. That's how it is. So altogether in total we have 14 sigma bond. We have 14 sigma bond, and I also have we have 14 sigma bond and 4 pi bond, and 4 pi bond. Although I don't know if there might be any irregularities inside though. You know how these things are. But ensure that each carbon atom has 4 bonds. Then the single bond will be sigma bond. The multiple bond will have only one sigma bond. Others will be pi. That is it. So let's look at this question. Now, if I ask you to draw this one now, here's 1 tyrrhodiene, 5 iron. Will you be able to draw it? It's a very simple thing. Hexane is the parent name. 6 carbon atom. 1, 2, 3, 4, 5, 6. Then you count 1, 2, 3, 4, 5, 6. Then in the number 1 and 3 carbon atom, we have a double bond there. So put double bond here, put double bond there. Then the number 5 carbon atom will have triple bond there. So you go to number 5, you put triple bond there. That is all. This is the structure of hexane 1 tyrrhodiene. So you can ask you how many pi bonds do we have here? We have one of this is pi bond, another pi bond here, and we have 2 pi bond there. So we have 4 pi bonds already. That's 4 pi bond. Then you can ask you how many sigma bond do we have? We have 1, 2, 3, 4, 5. We have a carbon sigma bond to be equal to 5. Then what about carbohydrogen? So just ensure each carbon will have 4 bonds. So just on this place, add one more. That's one more. Add one more to this one to make it. Add one more to this. Add one more to this. Then this one is already having 4. There's no need of adding to that again. Add one more to this. So you have 1, 2, 3, 4, 5, 6. That's what we're having. Having 1, 2, 3, 4, 5, 6. So carbon and hydrogen sigma bond is equals to 6. Is equals to 6. So total now. Total, if you total the what's it called, sigma bond, will be equal to 11. Then the pi bond is 4. So in total we have 11 sigma bond and we have 4 pi bonds. So in this place now we have 11 sigma bond and what? And 4 pi bonds. That is it. So thank you.